Alright, we have a word problem. The projectile is launched from a height of 18 feet. The projectile reaches a maximum height of 74 feet after traveling 40 feet horizontally. So we're going to start sketching what this might look like. So it's not launched from the ground, it's launched from 18 feet. So somewhere up the y-axis, we're going to have this projectile launched and come back down. It was launched from 18 feet up. So that means this point would be 0, 18. Reaches a maximum height of 74. So at this point, our height is 74 after it travels 40 feet horizontally. The path of the projectile can be modeled by a parabola where y is the height and x is the horizontal distance. Write an equation that models the kick. What is the height of the projectile after traveling 70 feet horizontally? So we want to know after it goes 70 feet, so somewhere over here, what is the height? We don't know. So this is our sketch. We need an equation. When you write your equation, you're either going to do intercept form or vertex form. We don't have our x-intercepts. We don't know what this value is here, and we don't know where this graph would come down on this side. So it can't be intercept form. It has to be vertex form. This is our vertex. So when we're writing our graph in vertex form, we're going to have an a value. We have a plus or minus h value and a plus or minus a k value. So we know we can fill in our x value for our vertex and our k value for our vertex. And then we need an x and a y. We know this point is on our graph. This is x, this is y. So we're going to fill in 18 and we're going to fill in 0. Now the only thing we have left to solve for is a. We have to follow order of operations, so we get a negative 40 on the inside. When I square negative 40, that becomes a positive 1600. Okay, I have to get a by itself, so I'm going to subtract the 74. Subtract the 74 from both sides, I get negative 56. And then I'm going to have to divide both sides by 1600. So I get negative 0.035 is my a value. So when I write my equation, the a goes out in front, the x goes inside with the x value from my vertex, and then the k goes on the outside. Okay. Now we have to do the second part of the problem. It says find the height. We wanted the height when it traveled 70 feet horizontally. We can do this two ways. We can do it algebraically. We can take our equation that we got and plug in the 70. So we would go replace the x with a 70, follow our order of operations, and then type that into our calculators. So if we have 30 squared, 900 times negative 0.035. So this is going to be negative 31.5 plus 74 is 42.5. The other thing we could do is we could graph this on our calculators. So if we graph this on our calculator, we have negative 0.035 x minus 40 squared plus 74. Our window, we know we got to make our window look like this. So we know we need our x max to go out to maybe 100 because I have to go out to at least 70. And then our y We need our y to go up to at least 74, so I'm going to make that at 100 also. And then we know we're going to see our picture. We can hit trace, and we can trace at an x value of 70, and we get 42.5. So that's another way you could do that problem. Okay, but you had to find your equation first. There's no way to do this without finding your equation first. Okay, so for the other version, same type of process. Our picture looks the same. It's the same. I don't even know why I'm drawing this again. It's the same information, except our question at the end is we want to know our height at 80 feet. So the steps for getting the equation are exactly the same. It's just our height part is different. So the equation is the same. Our height, we would plug in the 80 instead of the 70. You could also do it on your calculator, and you do trace 80 and you get 18. So everything would be the same for this one. Okay, for the last question, we have a graph given. We have to figure out the average rate of change and for where the function's increasing and decreasing. Average rate of change is slope. So remember, when you do slope, you do the difference in your y's over the difference in your x's. So on this graph, if I'm doing the increasing part, I'm going increasing from here to here. So I'm going to subtract my y values on the top. So I have 30 minus 20. My x values on the bottom. So I have 10 over 25. And then I can either simplify this fraction to 2/5, or I can change it to a decimal. It really doesn't matter either way. So this could either be 2/5 or 0.4. For decreasing, we're going to go from 10.4 to 30 and 60 to 25. So I have 10.4 minus 30. I get negative 19.6 over 60 minus 25 is 35. Now this is a decimal, so we really just want to change it to a decimal because we don't typically write a fraction with a decimal in it like that. So we're going to have negative 19.6 divided by 35, and we get negative 0.56. It should be negative because we're decreasing. That makes sense. Okay, what do these rates mean with respect to this graph? So if I look at these rates, if I ignore the negative part, the decreasing rate is faster than the increasing rate. So what do the rates mean with respect to the graph? It means that this human cannonball is decreasing at a faster rate than he's increasing. Okay? So we would say the cannonball is decreasing at a faster rate than it is increasing. Okay, that is it.